Alright, so now let's talk about probability with combinations. In a class exam will probably involve combinations playing the lottery, since the order that the balls are drawn does not matter. So let's do a few examples involving that. So the Texas Lottery is set up so that players select 6 different numbers from 1 to 54. To win a jackpot, a person must match all 6 numbers. A person can win a smaller amount by matching 3 or more numbers. So the first thing we're going to do is find the probability of one ticket winning the jackpot. So you got to think about it. Here we have 54 balls. I have to pick 6 of them that are correct. And it doesn't matter what order, so this is a combination. So we're going to do 54 C6. So I'm doing option 2 now in our probability. And that's how many ways the balls can be selected. And out of those ways, only one ticket's going to work. So our probability would be 1 over that number. So that would be a very, very, very small number. We can do the division, but you'll get a ridiculous number of zeros. Alright, let's find the probability of one ticket winning a prize. Well, if you match 3 or more balls, you're going to win a prize. So let's say if you match 3 balls, well, you know there's 6 that are winning balls, 48 that are losing. So out of the 6 balls that are winning, if you pick 3, and then the remaining 48 that are losing balls, you're going to pick 3. So this is matching 3 balls. Let's talk about matching 4 balls. Well, let's think about a number of ways we're going to do that. So we got 6 balls that are correct. I'm going to have 4. And then I got 48 balls that are incorrect, and I'm choosing 2. And then matching 5 balls. So I have 6 balls that are correct. I'm matching 5. I have 48 that are incorrect, and I'm picking 1. And of course, we've already talked about if you match all 6 balls, well, there's only one way to do that. So we're going to calculate each of these and add them up, and that will give us how many ways we can go ahead and win a prize. So let's do the first one, 6 PRB, option 2. So I'm doing NCR 3 times 48. This should also be a 3, I'm sorry. My bad on that one. Because you're picking 3 losing balls on that first one. Hit enter. So we have 345,920 ways that can happen. So we're going to write that down. So let's do the next one. So I got 6 NCR 4 times 48 NCR 2. So that's 16,920. And then we're going to do 6 NCR 5 times 48 NCR 1. So that's 288. And of course, this last one, there's only one way of doing that. So now I'm going to add up these 4 numbers, because that's the number of winning tickets there would be. So I'm going to cheat, just kind of arrow up here and grab these numbers real quick. Oops, a little too far. Plus, going to grab the second number. Oops, I messed that up, didn't I? Try that again. So I'm going to grab the first number, plus. Go and grab the second number, plus. Go ahead and grab the third number, plus, and I need to add 1 for the last number. So if I total those up, that gives me 363,129. That's how many ways I can win a prize. I'm going to put that over the number of ways the balls could be selected, which is from part A was 25,827,165. Now, I'm pretty sure this is going to blow up the calculator, but we can try it. Just putting that in, and sure enough, that does. It's approximately 0.014 for the probability of having a winning ticket. Now, if you look on the Texas Lottery website, at least they used to have, is they'd say you'd have about like a 1 out of 72 chance of winning. If I take 1 divided by 72, or maybe it was 1 out of 71. Yeah, it was 1 out of 71. I'm sorry, my bad on that one. They would say that you have about 1 out of 71 chances. Well, that's where they're getting that number from. Again, it's just approximation. Let's try another one. So example 4. We've got a group of 5 females and 7 males serve on committee. 3 members of the committee are selected to serve on the budget subcommittee. Find the probability that the subcommittee consists of A, 3 females, B, 2 females and a male, C, at least 1 female and at least 1 male. So let's just start with those problems. So the first thing we got to do is figure out what are the total number of ways we can select the committee. So you have 5 females and 7 males. That gives us a total of 12 people. And we're selecting 3. So this is just the number of ways the committee can be selected. So that's 220 ways. So that's going to be our bottom number on at least the first 3 examples. Now, we next want to see how many ways can we all 3 be selected so they're all female. Well, we got 5 females. Again, order doesn't matter here. We're selecting 3 of them. So we're going to do 5C3. So there's 10 ways that can happen. So our probability would be 10 over 220. That's 1 over 22. Or approximately 0.045. All right, let's do B. B, we need to go through and talk about 2 females and a male. So let's think about this. You have 5 females, and you're picking 2. You have 7 males, and you're picking 1. So we're going to have 5C2 times 7C1. So let's put that in our calculator. 5 NCR2 times 7 NCR1. So there's 70 ways that can happen. So now getting our probability, we're going to go ahead and put 70 over the total, which was 220. That reduces to 7 over 22. And let's get in a decimal approximation for that. So that's about 0.318. All right, at least one female and at least one male. It might be easier to answer the opposite. So if I've got a committee that's all females, or a committee that's all male, neither one of those count. All the other ones would count. So we're going to do this backwards. It's kind of like if you've got a tournament, like a basketball tournament, where you've got 64 teams playing, and with the teams, you have to have one winner at the end. Well, rather than bracketing off, trying to figure out how many games you need to have, if you think about it, if I have one winner, I need to have 63 losers. In order to have 63 losers, I have to have 63 games. So that's what we're doing here. At least one female, at least one male. Well, I'm going to find out the number of ways we can have an all-male committee, a number of ways we can have all-female committee, add those together, take that off from 220, and then that would then give us how many committees would have at least one female and one male. So, all-female committee, we've already calculated that back up here. There is 10 ways for that to happen. So I'm just going to rewrite that here, even though we've already done that. And then all male committee, there's 7 males, you're picking 3. So let's calculate that on our calculator. So that's 35. So if we add those together, that'd be 45. So that's 45 ways that can happen. So if we have 220 ways this committee can be selected, if we then subtract off 45, that would give us 175 ways that a committee with at least one female and one male can be selected. So our probability then would be 175 over 220. So let's reduce that. That reduces to 35 over 44. And then double arrow, that would be 0.795 if we round that. So almost an 80% chance of selecting a committee that's going to have at least one female and at least one male. Now let's change it up a little bit. Let's suppose that the subcommittee must have at least one female and one male, i.e. a subcommittee cannot be strictly all female and all male. Ooh, let's think about that. Well, we actually calculated above here. There's 175 ways. Now, they're telling us we cannot have a committee that's all male or female. So that's going to become our bottom number. So that changes the dynamic a little bit. We know from part B, so this was from part C. From part B, there are 70 ways of getting 2 females and a male. So that's going to be our top number, and that's coming from part B. So 175, we got it from up here, just bringing it down. And then the 70, we're bringing it down here. So we're going to write 70 over 175. We can go ahead and reduce that. That's 2/5. And that would be 0.4.